Hello everyone and welcome to AWCI's Limit Your Liability series. Today we will cover the emerging challenge of STC deficiency in construction. My name is Tanwin, AWCI's Education Program Manager. Let's just take a quick look at our agenda for today's presentation. A little housekeeping, speaker introduction, presentation, and a Q&A session at the end. So before we begin, a few reminders. Mics are muted. Should you have a question at any time during today's broadcast, please submit it using the question box in your GoToWebinar dashboard. The slide deck is available for download under the Handouts tab. I'd like to introduce our presenter, Don Pils. Don is AWCI's Director of Technical Services. He brings more than 37 years of experience in the construction industry as a drywall, lather, billing envelope consultant, and product development specialist. As a research and development manager at Semco for 17 years, he patented, developed, and successfully launched multiple products now sold across the U.S. So welcome, Don.
Thank you, Chow. Before we get started, I just want to read you guys a quote I recently heard. Life can only be understood backwards, but it must be lived forwards. I really like that quote. And in construction, as in life, we don't recognize what's wrong until we're looking back through a rearview mirror. But the good news is we can learn from those mistakes or from the mistakes of others. In this three-part series, I'll be sharing some of the most important lessons I've learned in past construction defects cases, mistakes that could have been prevented, and steps that could have helped reduce liability. Now, before we dive into this, I want you to do one more thing. Picture this. You're in the middle of a construction defects lawsuit. You just met with your lawyer. First thing they ask you, do you have the documentation to prove you did everything right? So now as we go through this presentation, I'm going to highlight key actions you could take to protect yourself from potential liability. All right, so the key takeaways for today, the objectives today. What are the code requirements for STC ratings? Where do you find them? We'll go over that. How wall assembly can affect the STC ratings. There's a lot of little things in there that we'll be going over. How movement can affect the STC ratings. The differences between field and lab tests. I think most of you will be surprised by that if you don't already know. And then the best practices to maximize STC ratings. All right, so first off with the code, it's really important as a builder to know the code, where to find it. You're going to find this in the International Building Code under section 1207. And what they're going to be talking about is the common interior wall partitions, the floor and ceiling assemblies, the separate dwelling places from one unit to another, and multifamily buildings. And what's that requirement? Well, it should be no less than 50 STC if tested in accordance to ASTM E90, that's a third-party test, or 45 if field tested. Okay, so that's a test requirement. Now let's get into what walls are actually talking about. So they're talking about the dwelling units, talking about the corridors, we're talking about stairwells and service areas, okay? Something else that's also recognizable in there, we're talking about STC, but notice something else about those walls. They're also generally your fire rated walls. We'll go into this. Fire tests and sound tests are completely different, but just keep that in mind. Generally speaking, if a wall has an STC rating, there's a good chance it's also going to have a fire rating. All right, back to the knowledge on this. So how long are third-party sound reports good for? Okay, well, according to the guideline for acoustics from ICC, it's no more than 20 years. That's what they're looking for. Okay, so that technical reference, it's going to specify the material, how it's built. It's going to give you a full description of that wall assembly, and it shouldn't be more than 20 years old. So always ask for a copy. If you've got a set of drawings where it's going to show a wall assembly, and maybe it'll show a third-party sound report, it'll just give the number. Ask for a reference, ask for a copy so you can read it, and then check the date, check the materials used. Make sure those materials are still available. Make sure you can build it that way. Make sure it was tested the way you're building it in the field. Now, I want to caution you about something. A lot of sound consultants rely heavily on third-party sound reports. I'm not saying that that is a bad thing. Of course they do. They have to rely on something, but some of these reports are 30 and 40 years old. It's good to know that. So you want to check. Back then, 30, 40 years ago, the composition of the gypsum could have been different. The steel thickness was definitely different. So there are some differences in there. When using a third-party report, treat it just like a fire-rated assembly. And what I mean by that is look at exactly the way it's built to make sure you could build it that same way. For instance, you might see some sound reports will have an 1.25 inch bottom track used for the head of wall. You might also see that the drywall screws were the framing screws went through the top track. These are all things that you're not going to do in the field generally. So you want to make sure the way you're building it in the field is the same way that it was tested. Okay, so how could the wall construction affect the STC rating? Material selection, drywall thickness, stud type, stud thickness, insulation, all that's going to play a role. Stud configuration. We all know as a general rule that metal studs outperform wood studs, but also the difference in metal studs and the gauge of the thickness of that stud will also affect the STC rating. Drywall, types of drywall, layers, that will affect it. Insulation, R11, mineral wool, R13, all that is going to play a factor. And then decoupling walls, that plays a big factor in it. Double walls, walls with a resilient channel or sound clips, it's all going to help prevent sound vibration going through the wall. And you're going to see kind of a theme through this. We're going to keep the walls flexible to increase that STC rating. So naturally, your perimeter joint should also be flexible too to reduce sound vibrations. All right, if you look at this, you might think, oh, they look like the same wall. And if you look at it really quick, it does look like that. They're both 3 and 5. But look at the difference in the STC rating. The one on the left is 40. The one on the right is a 47. What are the differences? Well, on the left, you've got a 20 gauge stud, space 16 on center. On the right, you got a 25 gauge stud, space 24 on center. And that makes a difference of 7 points. So pretty big swing. We're going to touch back on that slide later on. All right, we're going to go to one of the lessons learned right here. Okay, so I'm asking the question there, does this wall provide an STC 50? Now, why would I be asking that? Well, I know a contractor that had this condition on his job. He had a detail. Underneath the detail, it said STC 50, and it said and showed the fire rated assembly on there. Right. So as an estimator, you might be looking at this and okay, great, 3 and 5, single layer each side. That's the way I'm going to bid it. But when the architect put that STC 50, that's what they are expecting. So this particular contractor went ahead and bid it with a single layer on each side, built it that way. About 70, 80% through the job, the developer hired a third-party sound consultant to come out, started running tests, and you could guess what happened. They weren't getting close to a 50, getting into the 42s and 43s. Then they went back to the contractor and said, hey, your walls are underperforming. I said, no, I built it just the way you showed it. No, we were showing our expectation of an STC 50. You should have told us what it took to get to that STC 50. What that contractor had to do is rip off one layer of drywall, add RC, and put that layer back on there to get that up to a 50. Okay, so I'm pointing this out because just calling it a 50 STC doesn't make it a 50 STC. You've got to find out exactly what wall assembly you're going to build to get to that 50 STC. Okay, can you improve STC ratings by changing the mass from one side to the other? Absolutely, you can. You may have heard the term unbalanced walls. That's where you have a double layer on one side, single on the other, changing that mass from one side to the other. You can improve the STC that way. Here's another thing that we learned. In my previous employment, I worked for a metal stud manufacturer, and we had a contractor come up and asked us, they said, hey, I've got this job. I've got a requirement on the job to provide a 49 STC rating. And I had a sound consultant tell us that if we used abuse resistant board on one side and Type-X on the other, I could improve that STC rating by 2 to 4 points. Well, this was intriguing for us, so we went ahead and tried it. We did our base, which was Type-X on both sides, running around a 45, 46. We replaced it, put abuse resistant board on one side, and sure enough, got up to a 49. I was really surprised by that, but it shows you the effects of changing mass from one side to the other. This contractor got to do a single layer on both sides, saved him some money, and still provided the owner with a 49 STC rating. Now, the way you're typically seeing this more times than not is with a sound dampening board. And that makes a huge difference. Sound dampening board on one side, Type-X on the other is going to make a big difference in the STC rating. Let's take a look at that, what that looks like. So on the left, you got an STC 55 system, right? That is going to be just a 3 and 5 wall, 20 gauge, probably 20 gauge EQ stud there, 24 on center, and you got a 55. That's a great number, STC 55. Over on the right, again, you got single layer on both sides, but on this one, you added RC channel to it, and you got a 50. Okay, so pretty big swing there. Got the labor of adding RC in a layer of drywall compared to no RC, but more expensive on the material. So just two different options on there, but just showing that how mass difference improves that STC. All right, wall stiffness. How does that impact the STC ratings? Well, clearly, if I spread those studs out further, go to 24 in center instead of 16, I'm going to get a better STC. It's going to go down when I bring the studs closer together at 16 on center. Now, again, wood studs are going to outperform metal, but there's a sweet spot in there too, because as that metal becomes thicker, the thickness of the stud gets thicker, your STCs also go down. It's because the thinner the gauge, the less stiff the walls, and it gives you a higher STC rating. Now, in my opinion, there is a sweet spot in there. It's in the EQ 20 gauge studs, because EQ studs have generally the same steel thickness as the traditional 25 gauge steel studs. So you get the benefit of improved structural performance without giving up the STC values. All right, question for you. And again, this one has happened too. So what if you had a third-party sound consultant that requires 25 gauge studs, 24 on center spacing, but the structural engineer requirement for the job is 20 gauge studs at 16 on center? Again, you could have this on a job, both these requirements on your job. What do? Do you build it according to the third-party sound report? So let's face it, you save on some material, and then if anything happens, blame it on the architect for calling out the wrong wall. Or you say, forget that. I'm going to build it according to the structural engineer, and I'm going to disregard the sound report because, hey, it's got to perform structurally. Or C, inform the architect that there is an issue and ask for guidance. Obviously, the answer is C. You want to get guidance from the architect. This is a true dilemma here. What do? Ask them. Going back to that wall again, okay, that I showed earlier, STC 40, STC 47, just so you could kind of better understand why that's such a swing. Gauge of the thickness, the spacing of the stud, that is what changes that so much. All right, another kind of dirty little secret here. So many of the published sound reports will use the thinnest gauge steel available so they could get the best possible STC rating. Let's face it, if you're selling material, you're selling studs, you're selling drywall, you want to publish the best possible STC rating. And how do you do that? You do it with the thinnest gauge stud. But in the field, especially when you get down into 15 mil studs, the thinner gauge studs may have some limited application, limited heights that it might not be able to withstand or be able to provide the limiting height requirement for your projects. So you got to be mindful of that. Examples: door jambs, high walls, anything requiring backing, it's going to require thicker studs, 20 gauge at least for the load requirement on that job. Okay, so let's just go apples to apples with the stud thickness. All right, so data from the National Gypsum Soundbook showed that changing the steel thickness from 25 gauge to 20 gauge, same spacing, okay, just changing the gauge thickness will reduce it by 4 points. That's important to know. Okay, so I was just saying about that sweet spot right here, right? Okay, so here you got 20 gauge equivalent, that's your EQ stud. Notice it's generally 18 mil. Now, a lot of these tests that you'll see, especially the ones in the past, will be with a 25 gauge stud. And that drywall stud is also 18 mil. So what I was saying earlier, with a 20 gauge EQ, it's really that sweet spot because you get the increased structural properties out of it, and then it won't give up the STC values either. So it's a good sweet spot for metal studs. All right, before I go into this one, I'm gonna ask this question: what is the average STC rating on a door in residential? The reason why I'm asking this, I got invited out to go out to a job site to meet with the drywall contractor and the sound consultant, and just to hear them out on what some of the requirements were. And the drywall contractor said to the third-party consultant, said, hey, you recommended this sound report, 25 gauge studs, 24 inch on center, but I got to tell you, when I get to my doors, I have to do a double 20 gauge stud for my king studs on there. Can I do that? And I listened to the third party consultant, said, no, You can't do that unless you could provide me with a sound report that you could get that same STC ratings with 20 gauge studs, which obviously I just showed on the slide before. You can't. So I thought that was really strange because the average STC rating for a door residential is around 30 to 35. So it makes zero difference that you're using a 20 gauge stud because it's not going to change anything because the door's already reduced it. So if you ever run into that situation, remind the consultant that, hey, when I get down to the door, the STC is going down anyway. So it doesn't matter if I use a 20 gauge stud there. All right, back-to-back electrical boxes are another one. I recently took this photo on this job, and you could see here, I mean, you talk about back-to-back. We got one here, and eventually there's going to box that's going to go in here also. See, these are really back-to-back. Now, this is a double wall. Now, I was talking with the contractor, had nothing to do with the sound. We were talking about other things, and I said, hey, did you bring this up? I know you've got a reputable sound consultant on this job. And they said, oh, yeah. They came out and they already gave a fix. They wanted us to add drywall on the inside from here to here, stud to stud, 24 inches down and past. Now, I thought that's great because the third-party consultant got involved in there. And this is what I would recommend right now, right here. You're building your wall. You provided a sound report to the owner. You're building it to it. And then all of a sudden, you got all these penetrations in there. You need to speak up and ask about this because what you probably provided in your submittal package didn't have all these boxes and penetrations in there. So let them address it. The good thing about this job is that the sound consultant did come back with a fix. Now, I don't know if that fix is going to give them the STC that they want, but at least there was some involvement in there and they're trying to address the problem. Probably would have been best to do a mock-up test on it, but either way, at least it's being addressed. Now, remember earlier when I was saying that the majority of the sound walls are also going to be fire rated. Okay, so this is typically what you want to see. You want to see the boxes in different stud base, okay, for a fire rating. So keep that in mind. That's generally what you're going to see. Also here too. So again, just to dive down a little bit deeper, we don't want to see outlets in one stud bay, two of them. We want to go in opposite ones. All right. All right, so let's talk about a little bit more about that flexibility, airborne and impact sound transmission. Going back to that flexibility. So what we have here is a sound gasket here. You see this red gasket, and then you're going to have a hat channel that's going to attach into it, and that's going to reduce the vibration. So you can see how that rubber gasket is going to work there. It's going to reduce sound vibrations, and it's going to improve your STC ratings. Whenever you could get more flexible properties, it's going to have higher dampening characteristics, and it's going to reduce sound energy instead of transmitting it. It's going to reduce it. So that's another way that you could do that. The same thing with resilient channel. Now, something very important to note that not all resilient channels are the same. You have to read the sound report that goes with it. Also, you have to make sure that you're installing it right. Here's two things to look for. Notice on this first run, my flange is facing down. Every RC added above that, the flange is going to be up. You have to use a certain screw length with this, because if you use maybe a typical screw they might have in their pouch of an 1.1/8 or an 1.25" drywall screw, well, what will happen is if you screw it right here and it goes through the drywall, through the RC, it's going to touch that stud. Touches that stud, you short it out and you just negated any benefit you got from adding that RC channel in there. So you want to make sure you're using the right screws. You want to make sure you are reading the UL report. You want to make sure that the RC that you purchased for the job matches the the sound report also. So you want to make sure that's all together. Because if you ever got yourself in construction defects, they're going to go right in there. They're going to do forensic studies. They're going to make sure everything is exactly per that third-party sound reports. Also, one other thing just to note, if you are a developer and you're putting this out, keep in mind, once you hang shelves, once you do anything on an RC, you're kind of going to pretty much going to negate any value you gain by using an RC when you lock everything together. I think one of the easiest ways to maintain your STC rating is with a double wall. Okay, it's truly decoupled because it's two separate walls. So this is really where you see a big bump up in your STC ratings is when you go to this. The only thing, again, you want to be mindful from that picture is where are your penetrations. Okay, so just keep in mind for that. There's other ways to do this too. Now, I'm posing a question here. You may have already seen this. Why do some sound consultants require STCs over 50? I mean, after all, 50 is code. Why are they saying 55, 60? The reason why a lot of them are saying it is they're providing their client with belt and suspenders. They're telling their client, hey, there's a 5-point deficit that's going to happen if we field test this. And that's just, a common number that's out there. We want them to increase up to 55 so that when they field test, they're actually at a 50. So this is a lot of times they'll do something like this. So you'll see different products out there that could do this. This has got a gasket out here connecting these two studs together that again is going to reduce the vibration going through the wall. Or over here, they're just adding another layer on here. So maybe the wall requirement is just for a single, for a 1 hour rating, but you could see that they added double layer on both sides. That's for the STC ratings, not necessarily for the fire ratings. Okay, here's a few more that you're going to see. So again, with the sound dampening board, this one's taking it all the way up to a 60. It's a great number. Okay, sometimes condos will offer premier sound walls, premium sound walls, and they'll take them up to a 60. So this is a few different ways that you can get all the way up to a 60 STC rating. All right, the effects of poorly sealed joints. Okay, so sound can travel through air gaps. It's going to happen. Tracks, no matter how small, sound could get through them. And once you lose that acoustic barrier integrity, the joints are compromised. And now sound can get through that. And it's going to reduce your STC rating. It's going to create sound flanking paths. A crack on one side, a crack in a different area on another side, sound will find its way through there. Vibrational cracks, okay, that could happen too. Sometimes the walls are tall. You could have some structural vibrations, which could cause some cracks and unwanted noise transfer get through. High frequency, low frequency, like voices, that could go through from one side to the other. What's the solution? Permanently flexible joint protection. You'll hear some sound consultants call out that. I've seen it a lot in specs where they'll say permanently flexible sealant. There are some permanently flexible sealants out there that literally months later, a year later, you could press on it. It's still very flexible. The only thing that I caution you on that, if the wall is also fire rated, permanently flexible sealants aren't known for being fire rated. They're just a sound rated. Okay, again, back to that poorly sealed joints. So this you kind of see happen out on jobs. You'll see this. Now, this contractor looks like it was pretty well cleaned, but what happens if you got a dusty edge right here on your drywall, it'll create a small gap, and as it cures, it will come into a bigger gap. Now you might think, okay, it's not that big of a crack. What's the big deal? Well, if you're using a slotted track behind this, that's when it's a big deal, because the air will go right through, the sound will go through here, it'll hit the open slot, and boom, now it's on the other side of the wall. So something to look for in that. Now, how does movement affect the STC ratings? Okay, let's face it, walls are not static. They're going to be moving. There's going to be some dynamic building movement, and that can impact the STC ratings. You're going to have structural expansion, contraction, and you're going to have some movements that could create cracks if you're not building your wall flexible to be able to move without cracking. Okay, again, back over to poorly sealed joints. Now, this is when you've got some movement. Obviously, they've got some movement at the head of wall to the ceiling, to the wall, creating this big crack. Now, obviously, you're going to get some sound through that. Vibrational cracks. Okay, so gaps, cracks, vibrations will allow unwanted noise transfer through this. You've seen these before. These are pretty common coming off a door. You might see a crack like that. So buildings, materials, they are going to expand and contract due to temperature changes, external forces. So keep in mind, making a flexible connection to maintain this will really help the effectiveness. Again, stuff like this here. So what can you do? What could you do to mitigate that cracking? Well, control joints are great for that. You could put control joints. You see it coming down here vertically, going horizontally. These are also in the code, but they're in there for a reason. We want to reduce that cracking. Cracking could lead to sound going through it, and plus it's unsightly too. So control joints are going to help you with that. You can put them in the ceilings, you can put them in the walls. So in both areas. What are some key considerations when you're really looking at designing the optimal joint? What should you be looking for? Well, you want to see something that stays permanently flexible. Okay, that's important. And again, since so many walls are fire rated and sound rated, you want to make sure that that joint could provide a fire rating and an STC rating. And if you're going up to a concrete post-tension slab or something, you want to make sure it's providing somewhere at least around a ½ inch movement. You want to provide ample movement so you don't get those cracks that we were showing just earlier. Then you want it to make sure from aesthetic purposes, okay, if I'm designing it, I want to make sure that it remains flush with the drywall. In other words, there's some materials that you might have a recessed joint, which again, it's fine, but if you're looking at something aesthetically pleasing, you want it flush with the drywall, so that'd be another thing to look at. You want to make sure it's crack resistant. You don't want something that's going to be good for the first year and then eventually dry out and crack. So look for something that's crack resistant and then provides long-term performance. Okay, usually with those things that are joints that are permanently flexible, they're also going to provide long-term performance. All right, question for everybody here. If you got a sound consultant that demands that acoustic sealant to be used on all joints, I've seen this a lot, and the acoustic sealant does not provide the dynamic movement required by the structural engineer, who will take the responsibility when the sealant separates from movement? Okay, so you got one person, the sound consultant saying, nope, it's got to be acoustic sealant. That's my third party sound test. That's what I want you to use. But on the other hand, you've got movement in the building. Structural engineers gives you the amount of movement they want. That's disregarded. Who's going to take that responsibility? That is going to depend if the contractor brings it to the attention of the AHJ, the GC, whoever they're working with. If they bring it up, say, hey, we got an issue here. You're telling me to use a product that is not providing dynamic movement and it may separate. If you bring it up and they still say, hey, no, go ahead and use it, then in my opinion, the AHA, whoever signed off on it, should take the responsibility. So push that over. Make sure you bring it up, because I will tell you one thing. In a construction defects case, at the end of it, if you're the contractor, you will notice something kind of peculiar. All of a sudden, you are the smartest person in the room. They will say constantly through that, well, you should have known. You're the professional. So it's better to bring all this stuff up in the beginning, because they're going to blame you for not doing it in the end. So always bring it up. One thing I recommend is mock-up testing. I think it's a great way to just get everybody on the same page, all right? Instead of the field testing, of course, you could do field testing, but that's after the fact. I'm a strong believer in mock-up testing. Test it, and when you test it, make sure it's the dwelling suite is identical as possible to what's going on in the job. I mean, use the same labor, use the same products, use everything. And hopefully you have everything in there, the penetrations, the windows, everything else, and get a mock-up test, because acceptable performance is going to help validate what you're building. Hey, if it comes out and the number's good, everybody knows this is great, you're going forward, everybody's good. However, if it doesn't perform well, then you may have to switch that assembly, and it's way better to know it in the beginning than halfway, 3/4 of the way through the job. All right, so I was talking about this earlier, what is the difference between fire-tested walls and sound-tested walls? All right, so I was talking about that slotted track, that if you had a separation in here, here's your open slot, sound could get right through. All right, so the differences between sound and fire-tested walls is movement. This is what happens on a head of wall joint when you got to test for movement. They're going to cycle that drywall up and down for a fire test. But for a sound test, no movement at all. So it's important to know the differences between a fire tested wall and a sound tested wall. When movement occurs, acoustic sealant can split. It can pull away. If it's moving like I just showed in that video, it's definitely going to move and crack. Okay. Sound tested walls, it would make more sense to do sound testing on a wall after cyclical movement. It would make way more sense, but that standard has yet to be implemented. If there's anybody on the ASTM codes for sound, I strongly feel that this should happen. I mean, if you're on a job and I got one wall that's a firewall, one wall that's a sound wall, you realize both of them are going to move the same amount. Both of them are going to have that same head of wall movement. So why should they not be tested for head of wall movement? Fire tests are, sound tests should be also. Okay, so this is what the movement is that I'm talking about. All right, so this is dynamic movement under a building load. Okay, so you notice a couple things. So the stud is placed 1 inch down from the top, and this is so when that ceiling comes down and compresses, it could go down and go back up. So that's what they're looking for, down and back up. Maintaining a ceiling, a seal. So know the difference between fire tested walls and sound tested walls. Again, since sound wall assemblies have not been tested for dynamic movement, and most consultants adamantly require acoustic sealant everywhere, sometimes a contractor or an architect could be left out to dry if they follow the recommendations of a sound consultant who's insisting upon using just acoustic sealant for walls with dynamic movement. Again, this is something to bring up early on. The difference in how it could affect contractors. The contractors, there's contractors out there listening. You guys know you've got to build that wall for dynamic movement. You already know about that because it's in your drawings. You know you got to do it, how you got to build it. It's got to deflect at the head of wall. The structural engineer, because you're working with the structural engineer, the architects are working with the structural engineer, they're going to tell you how much movement that particular project needs. And you have to test it according to UL 2079 and provide that dynamic movement. That wall's got to cycle up and down 500 times. And then they open it up to the most wide open joint, and then they do the fire test. All that happens on a fire test. None of that happens on a sound test. All right. So if a wall is both fire rated and sound rated, which takes priority? They both do. Just like we're talking about in the codes, right? The code is going to require that 50 STC rating. It's also going to require fire rating. So both take priority in that case. All right, and I talked about this earlier. Just want to circle back on it. The majority of third-party sound tests are done with a 25 gauge stud, 24 inches on center. Now, I will say that some drywall manufacturers are actually getting some better sound tests out there with heavier gauge, 20 gauge. Some are getting into the 18 and 16, which is great. But just keep in mind that when you see that really high number on an STC rating, it's generally with 25 gauge at 24 inch on center. Now, high-rise construction cannot be built completely with 25 gauge studs. Okay, you're going to have some framed openings, you're going to have some doors, some windows that will typically, some backing, they're typically going to need 20 gauge steel in there. So like handrails, when you've got cabinets, when you got TV sets that got to be mounted, you're going to see that you might even have to increase it from 24 gauge to 16 gauge on center. Why am I saying all that? Well, because the sound report that you provided may be thrown out the window. Because once you change it from 24 inches on center to 16 inches on center, it's a different assembly. So be mindful if you're building to a third-party sound report and you can't do it, bring that up. So the difference is, again, between sound testing and lab testing. Let's talk about that. We just talked about fire. Let's talk about sound. Well, in a lab condition, it's very controlled. I mean, the drywall gets a white glove treatment out there. They're going to do everything they can to maximize that STC rating, where in the field, there's going to be a variety of different materials, backing, penetrations. That's going to change it all up. So there's a big difference between the way that both of them are tested. And then the quality, construction quality, even small deviations from the tested assembly can result in a lower STC rating. Now, that is partially the reason why you have that 5-point deficit that you get on a field test also. So with a lab test, you'll notice on the perimeter seal, this is something that I found pretty extraordinary when we were doing sound tests. They will take that perimeter stud, and a lot of times they put a gasket, kind of similar to that red sound gasket I showed earlier. They will take a piece of rubber and they will screw through the stud, through the rubber, into the test opening. What are they doing there? They're reducing that vibration. They're increasing flexibility. Can you do that in the field? Absolutely not. You can't do that. Why are they doing that? Well, if I'm a drywall manufacturer, I want the best possible STC rating. So I'm going to doctor up that frame the best I can to get that best STC rating. But you guys got to understand that in the field, though, we can't do that. So it's really good to look at that test. The better test would be the studs that are positively attached to that test opening without that rubber gasket in front of it. But again, I'm just pointing out some of the differences. And then they load up that outside with 1, 2, 3 tape. I mean, they pretty much completely take the perimeter gasket out of there, perimeter seal out of there. But this is what we have in the field, right? We got sealant in there, or we got a finished gasket going on in there, nothing else going over the top of it. So there's a difference in the field. Also, look at this. This is a sound test photo. Notice no penetrations, no cutouts. I mean, perfectly installed drywall, clean gaps all the way around, versus what we do see in the field. This picture is kind of comical to me. A lot of you guys probably see what I'm looking at here. This is an RC. This is backing for cabinets. They're going to install the drywall here, okay, through this. But then when they get the cabinet, they're going to take it and they're going to install it into this backing. That's going to negate all your STC values you just gained by using an RC. This is a perfect photo to show what you bring up with management, with the AHJ, because that is not going to perform to that third-party sound report with all that stuff going on in there. Okay, enhance acoustic performance. Let's talk about some materials that can enhance that flexibility in the joints. Okay, so there's a lot of these out there. There's a lot of different brands here where you could, this is a flexible foam that you could install. You're going to directly attach it right to the track, and then when the drywall goes over it, it's going to maintain that flexibility. Comes in different colors. Some of them are fire rated and sound rated. Some are just sound rated. So look into those. These are just different ways to do it, so you could, that flexibility will stay for the life of the assembly. These types of sealants, what they're called preformed sound stop. There's also preformed fire stop, but these would be considered a preformed sound stop, and they will keep that flexibility in that joint. A few different ways to do it. They've also got it in preformed, these where you could staple it to the wall. There's a gasket there that's going to maintain flexibility. That sealant could deflect up and down, and you'll have that flexibility for the life of the assembly. And then you just tape them in and they're good to go. Okay, so now that you know all of this, circle back on some of these takeaways here. All right, so the big thing that I was pushing is communicate. If you see an issue, bring it up. Because if you don't, in the end, you're going to be taking that blame if you don't bring it up early. So if you see it, bring it up. Make sure the third-party sound reports represent how your wall assemblies are being built. If it's not, ask for guidance. Again, they give you a third-party sound report, and it's showing an 1.25 inch track used at the head of wall, and your studs are screwed to that track. You can't build it that way. Bring that up so everybody's on the same page. Ask for guidance. Confirm that both sound walls and fire-rated walls provide the required dynamic movement. Okay, I just talked about how there's no requirement for sound walls to have any kind of dynamic test. There is for fire, but not for sound. So you might want to ask that question, hey, it's a little bit easier if you're going towards the fire side because you already know that provides the dynamic movement. But again, if it's just sound, bring up that question. Hey, this is a sound wall. Structural engineer said it's going to move 1/4 inch up and down. You're requiring a 1/2 inch joint with sound sealant. Where am I going to get that movement? So bring that up. Encourage mock-up sound testing. Again, you might think, it's a big upfront cost. It's a big upfront cost, but in the end, it could save a lot. Believe me, that one contractor that had to remove the drywall and add RC, he would have wished they had mock-up testing done in the first part of the job. That contractor had to pay for all that, which is a real bummer. But if you have mock-up testing early, you could find out if it's performing to their liking or not, and then you can make adjustments. Confirm that perimeter sealant joints will remain flexible and not negatively affect the finished aesthetics of the wall. So make sure that it's going to maintain flexible typically, just so you know, if they were just testing sound acoustic on the perimeter, they test it the same day the sealant is installed. And if you've seen the way sealant, after it shrinks and cures, it's a lot harder and it can split and crack. That will affect the STC ratings, but they never test it in that condition. They only test it when it's wet and freshly applied. Use common sense. Never assume somebody else is taking care of it, right? Because in the end, if you're the contractor and you're in sound construction defects case where sound not performing the way it's supposed to, everything's going to point to you. All right. So don't assume the sound consultant's taking care of it. Don't assume the GC's taking care of it. Take care of it yourself. All right. And that is our program. So Tal, pass it back off to you.
All right. Thanks, Don. So back in the presentation, you noted about differences in STC points. Like, can a human ear distinguish the difference of about 3 STC points?
I'm not sure if they were stating a fact or asking a question, but I believe that is correct. I think the human ear can only pick up a difference of 3 STC points.
Yeah, they were asking a question.
Yeah, that's basically. I've heard it's 3. I've heard some people say as high as up to 5. You know, I guess it's whoever's saying the quote and what's wrong with the job. Like if you got an underperforming wall and you're 5 points low, you might throw out, oh, the human ear doesn't even pick up to 5 points. I believe it's closer to 3, 4 range, but yeah, it's somewhere in there.
So on slide 45, you state that all head of wall top tracks are made of a minimum of 20 gauge steel. Is this a 20 mil EQ 20 gauge or a 30 mil? Can you specify that a little bit more?
It's a really good question. You're right, because there's like 7 different 20 gauges out there if you really get into it. So what we have seen, and again, this is for fire, right? So we have seen that it would be a minimum 30 mil 20 gauge stud. It's not the EQ. I have never seen an EQ 20 gauge track in a head of wall sound test. I mean fire test. I've never seen it. That doesn't mean it's not out there, but I have a pretty strong feeling I would know if it was. Difference is, you know, there's a lot of structural integrity, especially when you have slotted track and yet fire's going right through there. You want a thicker gauge material. You don't want to go down to like a 25 gauge in there, because what happens is that track will oil can. I've seen that happen. Once it starts to oil can, that heat could pass through a whole lot easier. Great.
And then are there a lot of acoustical ASTM changes throughout the year?
You know, that's a good question. It's one of those ASTM committees that I'm going to get involved with. But if anybody's out there involved in ASTM, you know things go very, very slow. So I would say no, there's not a lot of changes that are happening. I think a lot of things get proposed. So I think it's, you know, like earlier when I was talking about know what the codes are, I think it's important to get involved with ASTM. Maybe not join the committees, but at least have somebody in your organization that is getting updates. There's different organizations that will do this. AWCI is going to be doing this with the CTC committees, so we're going to be keeping everybody up to date on any types of code changes. So that's one way to do it, but it's pretty slow, I would say. But I don't want to discourage anybody. You still should get involved, but things just don't move that fast.
Well, thank you so much. That concludes our Q&A session and our presentation. Thank you, Don. Thank you to the attendees. We hope to see you soon at Build 25 in Charlotte. You can join us. Please visit awci.org/events calendar for more upcoming webinar. We'll see everyone next time. Thank you.